All right. I think we've got a quorum here of number. Things are looking good, and the trickle is slowing down a little bit. So I'm just going to go ahead and get started. Welcome everyone to our webinar. We're talking about Apache Hive to Iceberg style migrations today, and what are the considerations and patterns and tools that are available to you to make moving your existing data lake from a Hive managed data lake to an Iceberg type data lake. I'm Cliff Gilmore. I'm a principal solutions architect at Tabular, focused on helping our customers be successful with their data lakes in Iceberg. Joining me today is Jason Reid, who is a co-founder of Tabular, been one of the drivers of Iceberg over the years, and our head of product here at Tabular. I'm going to start out talking about some of the considerations and overview of what a migration looks like, the things you have to think about as an organization to be successful with a migration. And then Jason will get into some of the more technical weeds of the tooling that's available and the nuance that's out there in terms of how do you actually orchestrate a migration and what are the capabilities that are out there for that. And then at the end, we'll take some questions. So like Jason said a minute ago, please drop your questions in chat, and we will address them in the last 15 or so minutes of the talk. So anything is always, I'd be remiss to not talk about, Apache Iceberg and why we're doing a migration in the first place, because the why is always important when we're talking about migrating and what are we getting from moving to Iceberg. And a lot of the core concepts of Iceberg are around making your data lake behave more like a data warehouse. The first piece of that is adding SQL-like behavior. Being able to alter tables and have the correctness guarantees like ACID compliance that you would expect from working with a data warehouse. Some of the other challenges of a data lake are things like schema evolution. If you're coming from Hive, you probably well know that evolving a schema comes with a lot of pain and problems and edge cases and breaking changes and things like that. So Iceberg provides seamless schema evolution so that you can modify your tables over time and not have your applications and Spark jobs and things like that break. It also adds hidden partitioning, because partitioning is something that does change over time and should not be something that the query engines have to know about. It's really focused on structuring the data correctly and optimizing for query patterns and being able to change that over time as those query patterns change without having to rewrite the whole table. Being able to change in place partitioning for files going forward is a big deal. Other reasons where Iceberg is really important are things like time travel and rollback. So as you adopt a data lake, you might have, for compliance reasons, a need to go back in time and query the data, or for other use cases where you want a point-in-time picture of the data. Or, let's say an application that was writing to your lake spewed out a bunch of garbage into your table. You might want the ability to roll back to a point in time before that application change was first committed. So these are all things that Iceberg provides and add value to your data lake and make it behave more like a database. A huge win you can get from going to Iceberg is the capability to do compaction. It's a little out of scope of today, and that we're not going to talk about how it's done, but it is a hugely valuable capability of Iceberg in that it lets you really optimize the way your data is stored within the lake and save costs in terms of S3, or GCS, or wherever your Iceberg files are stored. But it also gives you the ability to compress it and structure it in a way that your query engines can touch the least amount of data. And that's directly correlated to performance and cost at your query engine layer. And then there's the REST-based catalog specification, which is an Iceberg-centric worldview based catalog that gives you a lot of the things that you would expect, like transactional semantics across tables in the future, and the ability to communicate with the catalog, which allows catalog implementations to add things like role-based access control and other capabilities that are specific to having a place where Iceberg metadata is stored and retrieved. So that's an important part of it. You can certainly use Iceberg with a variety of other catalogs, which I'll talk about in the beginning of my talk. And each one has implications. But these are kind of the big whys of Iceberg. There's others, but this is the the core things that drive folks to adopt Iceberg. So to get to the meat of why we're here today, there's a lot of considerations when doing a migration, especially for something as large and as central as a data lake. You have to really think about what your requirements are. So as with any migration, there's trade-offs to be made. These trade-offs can be things like sensitivity to downtime. Do you need a migration that will work without any downtime to any of your query engines? Can you tolerate a little downtime as you switch over things? How much tolerance do you have to changing things, right? So can you go into your queries and update the source table, or do you want to try to do it in place so that they're unaware of the change under the covers? And what is your tolerance to that change? And then configuration things that need to go downstream. We also want to think about, cost flexibility. So one of the ways a lot of people do migrations is just to write the data twice, right? Have one pipeline that writes to your normal format and one pipeline that writes to the Iceberg format. And that's clearly the cleanest way, because then your applications can fail over to the new format whenever they feel like it. But it also means that you have to maintain that second pipeline and orchestrate and ensure that it's in sync with your existing environment for the time period at which you want to allow that migration to happen. And obviously it's expensive. So at extreme scale doesn't make sense. And then, what is your architectural change desire, right? Do you want to continue to use your existing catalog? Does the Iceberg catalog add benefits that you think are worthwhile? And what tools do you plan to use in the future? Are you adopting Iceberg so that you can add new query engines to your architecture, like your Snowflake today, and you want to be able to support Spark and Trino in addition to it in the future? So that kind of architectural change will drive a lot of your decision-making in the migration. So there's kind of two real paths to an in-place migration to Iceberg. One is, instead of rewriting all of our data to Iceberg, we just convert our existing Parquet files and so forth to Iceberg version by writing new metadata. This has pros, which is you only have to rewrite the metadata, so you're not processing like a petabyte of data to create new Parquet files. And it's obviously faster. You get it done quicker. You'll be able to make those data available a lot earlier than you would if you had to rewrite the entire file. Your existing Hive table definition can still read the table. You just have to tell it that that's now an Iceberg table for new applications. The downsides is you don't get some of the Iceberg perks. You're not going to do hidden partitioning on your old Parquet files. You won't be able to compact them without converting them to the Iceberg format, and compaction would do that to them if you turned it on or ran it. And obviously, it's going to have a higher cost because you're not getting the value proposition of compaction and optimization that can be done within Iceberg. So you're not getting the big win of the migration for your existing data. You're just getting it on new data that flows in. The other main pathway that we see is a full rewrite. A full rewrite gets you all the Iceberg benefits. So, that's a biggie. It's in bold for a reason. For tables that are critical or high volume, high query load tables, it probably does make sense, even if they're large, because the benefits of size and compaction and partitioning and correctness and so forth are so critical. It has less long-term cost because of the compaction. The downside, it's going to take longer. If you have a petabyte of data, rewriting a petabyte is never going to be fast. And your table definitions do have to change, to be the Iceberg specification, and your applications now have to understand that the data is an Iceberg, because the Hive definition will no longer exist to this table because it's been rewritten as Iceberg files. Now, this is not an all or nothing decision, or you can actually choose for on a table by table basis what makes sense. So you might full rewrite certain critical tables, and for tables that aren't commonly used and are just fine in place, you can leave them in their existing Parquet and write the metadata on it. So we actually expect most folks to do a hybrid of this that have large existing lakes, just because the advantages of Iceberg are focused on tables that have the most need for it. However, there are reasons to do the full rewrite on everything if you so choose. Up to you. And then you have to make a choice on the catalog. So today, with Hive-based Parquet things, you're probably either using the Hive metastore itself, or you're using AWS Glue, well, that's a very common catalog that we see. And those will continue to work, so you can stick with those. However, you now have a third option, which is the Iceberg REST catalog. And this is something that we work on here at Tabular. We have an implementation of that REST catalog, and it has benefits, right? Because it's a single place where you communicate with metadata against Iceberg. You can do a lot more coordination, statistics gathering, auditing, and other good stuff that you would want from an enterprise grade lake. And everything is going through that catalog, so you can deal with things like contention on the right side and other challenges that you would have going directly against the file system. The REST catalog has wide support today. It's supported by tools such as Athena and Spark EMR and Trino and so forth. And it's on the roadmap for a lot of the other common readers, things like Snowflake out there that will eventually support the REST catalog. It is the modern way to approach working with Iceberg. It is an open spec, so it is part of the Iceberg project itself. And there's the idea is that different vendors, different implementers can release implementations of it, like we've done at Tabular, but the spec is open source and thus it's universal. So if you support one REST catalog, you should support them all through that REST interface. So there's a couple other places where we have to think about. One is, what's reading my data? You would think this is easy to know off the bat, but you'd be surprised. The whole value proposition of having a data lake is you can bring lots of different processes and teams and lines of business to bear on the same data. What that means is sometimes it's hard to know who is using it. And that's kind of critical to know for migration, because if you break your users, they're not going to be happy. So the first thing I always suggest is identify who's reading what. You can do that using something like an S3 storage access log or other access logs across your system, and just your organizational knowledge. But you will need to know this because you'll want to orchestrate updating the environment, and your decision-making process will be somewhat driven by how much you know about the overall ecosystem of your reading things. The other is, what is the impact if you do change the catalog? How do you, handle that, and how do you update your readers to use that new catalog? Even if you're using existing catalog, some of the paths that we'll talk about do require you to update the naming scheme, right? Because the catalog name might change, or it might be a new table definition because you want to preserve the existing table definition. There's a lot of trade-offs that you have to know. So think about how your catalog is going to be impacted by this decision. The next is the naming scheme, right? So traditionally, in some of these catalogs, you use just the second and third parts of this naming scheme, which is catalog, database, table. You probably want to start using ahead of time as like a preparation for a migration, the fully qualified 3-part naming scheme, because this will allow you to make some of these changes more cleanly and adapt to things when we talk about doing in-place updates of the metadata. Again, this availability need, right? So do you have the ability to update each one of these query engines, and what happens while we're running the migrate? Do you want to continue to be able to read from Hive, or do you want to take a little bit of downtime to have an easier process? This is really, really, really relevant, and it will drive some of your decision making. And then, for some engines, configuration changes are easy. Like Trino is just to go into the properties and update it. For other things like, say, Spark, you do have to set your Spark job configuration across all your Spark jobs. If you have hundreds or thousands of those, then that could be a pretty heavy lift. So that will drive your migration design, because you have to think about, do I need to support the existing jobs that haven't been updated even after the migration is complete for some period of time? On the writing side, it's the same configuration changes, right? Do we want our writers to continue to write to the Hive Parquet format? Are we planning to change them all over to Iceberg Parquet right away? Those will drive, some of the tooling you need to use, because if we continue to write to the Hive style Parquet, then we have to convert those new files to Iceberg as we go. Jason will talk about that more in the future. You have to think about, how you want to orchestrate a switch over, right? So what are the prerequisites on the reader side and the catalog side to start having your writers move to Iceberg? You probably don't want to start writing Iceberg if all your readers are still reading from a mix of Hive and Iceberg. You probably want them all to be reading from Iceberg before you switch your writers over. The dual write conversation I talked about earlier also remains relevant in this world. And then for new options, we have some new cool stuff we can use. So, if you have event streams coming in, now that we have Iceberg tables after a migration, we can use things like the Iceberg Kafka Connect sync and skip a step in our warehouse, right? So instead of writing to S3 directly with Parquet, or other cloud storage directly with Parquet, we can now use a direct write to Iceberg. This is something that's open source. It's out on GitHub. We wrote it, but it's Apache 2 license, so please use it. And then, tools like the Flink Iceberg sync to give you exactly what's processing and, all the way through Iceberg and so forth. And here at Tabular, we have a file loader that allows you to load file streams and files into Iceberg format without an extra step of raw Parquet and S3, or use raw Parquet and S3. And file loader will attach it to your tables or optimize it for you on the load path. So there's kind of two main architectural approaches to a migration. I'll let Jason talk about the specifics of these from a technical perspective, but overall, and don't worry about the number of arrows here. A lot of it's just showing before and after state without having to do transitions. But if you look at the state of the world, ignore the things in blue. We have things that write to cloud storage. That data generally ends up in Parquet. I do want to say that Iceberg also does support Avro-based and Orc-based files. Most of the users we see out there use Parquet, so that's the default I assume here, but it is not required that everything be Parquet. So in this case, we have, Parquet writes. We have a catalog that defines the table structure across those Parquet writes, and we have readers of the data that talk to the catalog. It gives them an S3 or a GCS or ADLS bucket location, and then we're able to process that data. As part of a migration, we need to add what's in red down at the bottom, which is if we're doing a metadata conversion approach, which is what this is showing, we have to run what's called a snapshot. And what a snapshot is a Spark job that runs, and it builds Iceberg metadata for all the Parquet files that already exist. And this, effectively converts that old Parquet information into an Iceberg readable Iceberg table. It does not touch those files. Those Parquet files at the above stay the same. And then as new writes get converted over to Iceberg, they talk to that metadata and then they write Iceberg native Parquet files to the storage, right? So this is the new version of the table. And these coexist. So we're able to, after the migration, read from a mix of the original Parquet and the new Parquet using the same Iceberg metadata. And this allows, us not to have to rewrite all that old Parquet information that we've accumulated over a long period of time if it doesn't add value. Sometimes it does add value, which is what the next approach is for. There's one other consideration here, which is in blue on the left side, which is if we are continuing to write to Parquet for some time after we run the snapshot, we do have to use a tool like the add files Spark job that Jason will talk about later to register these files and build their Iceberg metadata until we're ready to switch all of our writers over to a native Iceberg format. So that's the downside of continuing to write to Hive and support engines that haven't switched over, is you do have to have a continuous process to convert new files into the Iceberg format. Another approach is the rewrite approach. This is more of our hard migration, where we are going all in on Iceberg. In this, instead of running snapshot, we run a Spark job called migrate. And what migrate does is it actually rewrites all the Parquet files. So you notice there's an extra arrow off of migrate from that box where it actually writes all the Iceberg Parquet files. So we no longer need the existing files in our cloud storage, and we're able to rely completely on Iceberg and get all the benefits of Iceberg. So, the hidden partitioning, the ability to compact and optimize these files, and all that is now on our whole table, not just the new data that flows into our table. Um, so this has those benefits. Obviously, migrate is heavier weight than snapshot. It costs more compute and it takes more time, and it's going to incur more, S3 read and write cost. But the advantage is we can now retire those Parquet files and have a fully optimized Iceberg environment. And then afterward, our reads have to be from Iceberg metadata files. Our writes can use the same pattern as before if we need to, right? We can continually convert new Parquet files to Iceberg as they come in, but it's not as ideal to do it that way. This is a little bit of a harder migration or a more all-in migration attempt, but you get all the benefits of Iceberg using these. So for critical tables, I'm probably going to recommend this path because we do want that smaller file size or smaller overall file footprint, more efficient file structure, all the good stuff we get from Iceberg is fully realized in this pattern. So there's a lot of nuance to these moving parts and how you orchestrate these, how you handle the catalog so that, readers can use the same table definition to do all that. And Jason will get into that here when I hand it over to him. But these are kind of the core paths and pathways into a migration. So now I'm going to go ahead and hand things over to Jason. He's going to pick up for the next half, where we go a little more technically deep on these moving parts.
Awesome. Thanks, Cliff. Thank you for being my driver across the slides here. So let's go ahead and get into it. So we're going to talk in a little bit more detail on these Spark procedures that do the various flavors that Cliff just went into. And I'll try and sprinkle in a bit of my own experience doing this at Netflix. Obviously, we had, I think, hundreds of thousands of tables that we migrated over a long time window. So, what we see most folks who have, large lakes, like Cliff mentioned, is this is going to be probably a long migration, and you're going to go table by table and make these decisions both on timing and which style of migration to use based on the business needs around particular data sets. So you don't have to do this as a big bang. In fact, I recommend that you wouldn't, and you do these things piecemeal. But it's good to think about all this stuff ahead of time that Cliff mentioned, so you can have a clear plan on where you are and where you want to end up, because that will definitely determine the different mechanisms you use. All right, so prerequisites for actually running the stuff I'm about to show, just so you all are aware. This is assuming that your Hive tables obviously are backed by some sort of Hive metastore, or that can be AWS Glue. Both will work for what I'm talking about today. Relatively recent versions of Spark and Iceberg. Some of this stuff goes back into older versions, but all the procedures that I'm talking about today definitely exist in these later versions. I'm going to talk about how to use a Spark session catalog, which is a special kind of Iceberg catalog in Spark that allows sort of a mixed mode of Iceberg tables and Hive tables. That's the magic you need to do some of these snapshot and migrate operations. You also will need the IcebergSparkSessionExtensions. So these procedures that we run in Spark aren't native to the open source Spark. They come as part of the Iceberg Spark runtime, and it's just configuration that you'll have to set. And then for these particular Spark functions, they do require that your Hive tables are either in Parquet or ORC file formats. So if you're using text or sequence files or CSVs as part of your Hive tables, these options aren't possible. You have to go through the basically full rewrite path that Cliff mentioned earlier. You would just need to create an Iceberg table and then do insert into select star from, or create table as select star from your existing Hive table to get those into Iceberg. All right, on to the next thing. Yeah, we'll back up. Oh yeah, here's Spark procedures. So these are the four that I'm going to talk about. These are all pretty well documented actually in the Iceberg open source docs, and the link is there. But you have these four, and we'll talk about these in detail. But at a high level, snapshot, like Cliff mentioned, is same data. We're not touching the underlying Parquet files. We're just going to build Iceberg metadata around those files, and we're going to register, basically create a new table entry in the Hive metastore or in whatever Iceberg catalog you're using. So you'll have at the end of the snapshot two tables. You'll have both the original Hive table and you'll have an Iceberg table, and those will operate independently. Migrate, is, like mentioned, heavier weight and more of a stark cutover kind of operation. We're going to basically do the same thing we do with a snapshot. We're going to same data files. We're going to wrap that stuff in Iceberg metadata. But instead of creating a new table and leaving the Hive table in place, we're actually going to basically replace the existing Hive table entry in the metastore with an Iceberg table entry. So henceforth, after that migrate, all reads and writes have to be using Iceberg clients, otherwise they'll be broken. So definitely have to make sure that you're coordinating, usually a little downtime, and you have to cut over your readers and writers like all together. So that one is more coordination, but gives you a clean Iceberg table on the other side, as Cliff mentioned, has benefits. Add files is actually a procedure that underlies both snapshot and migrate. This is like choose your own adventure. This is like you're taking a Parquet or orc file and you're directly adding it to an existing Iceberg table. So you have to create the Iceberg table, define its schema, and then you can add an existing file. So without having to rewrite the file, you can just add the file to the Iceberg metadata. There's definitely a lot of rough edges for doing that. You have to make sure your schemas match, and you can get duplicates if you're not careful. So it definitely is sort of a power user type of procedure, and should be used with caution. We'll talk about some of the risks. And then lastly is the register table. This is less about actually migrating a Hive table, but it's useful in particular if your end state is going to be, hey, I'd like to get out of the Hive metastore. So most of the stuff we're talking about is creating Iceberg tables, but in your existing Hive metastore. So you're still, using HMS or Glue. If you want to move to something like the Iceberg REST catalog, then eventually you're going to have to, after you create that Iceberg table, register that in the new catalog and basically remove it from the Hive catalog, which has a lot of other advantages that Cliff mentioned. And so we'll talk a little bit about how to go about doing that. Okay, getting into the details. First things first is making sure that we get our Spark environment configured correctly. You're probably going to want to, as Cliff mentioned, get your Spark clusters with this configuration so you don't have to go and touch every single job. You can do this on a job-by-job basis, either if it's Spark SQL or Spark Submit or PySpark, however you're using Spark is fine. These configurations are the same across the board, but you probably want to eventually set this at your cluster level so that all your individual jobs and users don't have to think about these configurations. So the first thing is, make sure you get those Iceberg Spark session extensions. So this is like just telling your Spark environment that I have procedures that I want to be able to run that come from the Iceberg package. This assumes you have the Iceberg Spark runtime jar somewhere in your class path. The second line there is kind of a trick that I think if you haven't been familiar with using catalogs in your Spark environment before, you probably didn't know really what was going on underneath the covers. So Spark's default catalog is actually this catalog named Spark_catalog. If you're working in a Hive metastore, you probably don't often use a three-part identifier. You're probably just using database name dot table name to address your tables. Select star from mydb.mytable. But in Spark, there's actually a catalog there, and it's just defaulted to being this Spark_catalog. This is just a universal name that Spark uses for its built-in catalog that is often backed by Hive metastore. And if we want to do these procedures where we're having snapshot and migrate, and we have a mixed mode of both Hive tables and Iceberg tables, we need to set this up. We basically need to say, hey, Spark, for your default catalog, we actually are going to use a SparkSessionCatalog, which is this Iceberg implementation that handles bouncing back and forth between Iceberg metadata and the underlying Hive metastore. As part of setting up that catalog, you give it a base path for where all your tables are going to get created, any new Iceberg tables that are going to get created. And in this case, we're going to say the type is Hive. And I recommend, this is maybe optional, but we would definitely recommend using Iceberg S3 file IO or whatever object store file IO you're using. There's a GCS one, there's a Azure as well. This would just be more performant than using Spark would natively just use kind of a Hadoop based file system. even if you're in an object store. And so using these object store specific file IOs will just perform better. There's a lot of file API that all these procedures use, and it's more efficient using the specific file IOs. So that's for Hive. And if you're using Glue as your backing Hive Metastore, it's the same exact setup, just that the catalog type is needs to be specified as the Glue catalog. And actually, the typo in that config, you need to use the catalog impl is actually the name of that property. So we'll put that fixed in the slides. Okay, so that gets our Spark environment set up. We actually can talk to our underlying Hive Metastore, but now we can support Iceberg in that catalog environment. So here's an example we're going to use throughout the rest of this this webinar. Let's assume that we have this Hive table. It's a very simple Hive table, 3 columns. It's partitioned on this date string column, and it's stored as Parquet. And let's just a single value into a single partition in this column, and then we're going to look and see what happens when we run these various procedures against this table. So we have a very simple Hive table. This can be as big a table as you want it to be. It can be a table of a petabyte of thousands to 10,000s of files. All these things will work the same. All of it will be distributed by Spark. So you can crank through even very large tables using these procedures. All right, next one. Cool. So first one we're going to talk about the snapshot procedure. So as we talked about, we have to use the catalog name when we are calling these procedures. That is the catalog that Spark will look in for both our source table as well as the catalog it's going to create the new table in. So Spark catalog here, so because it's the Hive Metastore backed catalog, and we're calling snapshot with 2 required parameters. One is what's the Hive table source? So we're going to use the one that we just created in the previous slide. And what's the name of the Iceberg table that we're going to create? And remember, when we snapshot, we're actually we're gonna use the same exact underlying Parquet files, but we're going to create Iceberg metadata, create an Iceberg table, and make it as a new table entry in our Metastore. So after the snapshot call, we'll have 2 tables. We'll have db.hive and we'll have db.snap1. One will be Iceberg, one will be Hive, but they're going to share the underlying Parquet files. So it's good to understand that. If you mess with those underlying Parquet files, you could break one or the other of those tables. So just good to be aware of what's going on. If we then do a select from our Iceberg table that we just created as a result of the snapshot call, we can see exactly what's going on. We have the same exact one record. It's got the partition. So the snapshot and migrate commands will carry forward Hive partition semantics into your Iceberg table. So that's nice. You don't have to worry about that. Be taken care of. And we can see that the path to this Parquet file is the same exact path as it was for the Hive table. So even though our table is called snap1, the Parquet files are still living at this db/hive and the partition pathing in our object store. And now we can describe this Iceberg table and see a couple more really important pieces of what happened as a result of running snapshot. The first one is that because these Parquet files were written using standard Hive, and they weren't written using an Iceberg writer and directly using the Iceberg APIs, they don't have field IDs in the Parquet file. Field IDs are something that Iceberg uses to manage schema evolution in particular. And unless you're using Iceberg Parquet writers, your Parquet files are likely not to have field IDs. And they're certainly not going to match up with the ones in the Iceberg metadata. And so one thing the snapshot procedure does is it actually creates a table property in the target Iceberg table that handles this name mapping. And this is what future reads, Iceberg reads on this table will use in order to line up your Parquet columns, because your Parquet files will just have column names, with Iceberg's column field IDs. So that's a really important piece that helps make all this work. And if you do evolve the schema of the Iceberg table, you'll see this name mapping also evolve. So you can still do some amount of schema evolution and be backwards compatible with your old Parquet data. And the second thing that's important is it sets a property called snapshot equals true. And this is super important because it is a property which will prevent other Iceberg maintenance operations from touching the old data files that are now shared between this Hive table and the snapshot table. As I mentioned, we have shared Parquet files. Normally, in a standard Iceberg table, as you commit more changes to the table, eventually you're going to expire snapshots and do sort of clean up old data files that are no longer part of the table. But in this particular case, because they're being shared with the Hive table, we don't want those data files to ever be cleaned up as part of Iceberg table maintenance. And the snapshot equals true is an indicator to Spark that it shouldn't clean up data files. But if you're using other compute engines and you're running, other optimization or table maintenance jobs, that may not be followed. So just be careful that you're not deleting data files when you're in this snapshot mode. Okay. And then the last thing I wanted to show was that the metadata that we created, right? Remember, we took the original Parquet files, we created a bunch of Iceberg metadata. The metadata for that table is stored on a path that matches the Iceberg table pathing, right? So the data files are still under db/hive/partitions, but all the Iceberg metadata you'll actually find in your object store under db dot, Iceberg table name, in this case, snap1/metadata, which is Iceberg standard path for table metadata. And so you have metadata on one path and your data file is still living on the original Hive path. All right. And then the last thing I want to say is, like, once you've got the snapshot, those two things operate independently. So changes to either the Hive table or the Iceberg table are independent. Remember, deletes will be very problematic. So don't do that when you're in this state. But if you're doing inserts and appends, you're pretty safe here. They'll be independent. So any writers that are writing new data to the Hive table can do so, and they won't impact the snapshot, the Iceberg snapshot table, and vice versa. You can write into the snapshot table and check my slides. That second insert statement, they should be inserting into db.snap1. And then we can get new records in the Iceberg table, but they won't be in the Hive table. This is a really great way. In particular, we use this primarily in a migration scenario to do our initial proof that all of our readers and writers can work successfully with the Iceberg version of the table without having to touch anything with our Hive production table. So we create a snapshot. Everything that's reading and writing to our existing Hive table is not impacted at all. And we can do a bunch of testing on the snapshot of that table without having to rewrite a bunch of data. So it's a pretty fast operation. We can test writes and reads from the Iceberg table independently, sort of before we're doing anything with our production customer traffic. That's a really good way to just test that everything's working before you go through with, we'll talk about next, which is possibly using the migrate command. So here we're again calling the Spark procedure, but here it's a migrate. So there's a single required parameter, which is what table, existing Hive table, are we migrating? And this is going to do a similar thing that we did with snapshot. It's going to use the existing data files, Parquet data files or data files. It's going to all the Iceberg metadata, but this time, since we're doing a migrate, metadata will actually be created on the existing path where all the existing partitions and data files already exist. And then it will replace the Hive metastore entry for that table with an Iceberg entry. So any reads or writes to this table after this migration call is completed have to be using the Iceberg APIs. Otherwise, you're likely to get a corrupted table. So just got to be very coordinated when you use this procedure to switch a table over. It's convenient in the sense that you can still use your two-part naming convention. Everything's still in your Hive metastore. So potentially not a lot of code has to change outside of ensuring that your readers and writers are using the Iceberg APIs to read and write the table. So using your access logs and other mechanisms to ensure that's happening is definitely a recommended approach. Okay. Yep, this is just reiterating what I had said. You have to go through Iceberg APIs for correctness. By default, there is a backup of the original Hive table that's created. So we replace the existing Hive entry, but the migrate procedure does create a backup table entry in the Hive metastore. And the default is underscore the table name underscore backup underscore. You can set that as one of the parameters of the procedure if you want to call it something else, but you do have this backup. That being said, rolling back to the backup is not a straightforward thing to do. So you don't want to necessarily plan on rolling back if you can avoid it. If you do need to, and you haven't made any changes to the Iceberg table, you haven't written any data or deleted any data or run any compaction, then you can take the Hive backup metadata and replace the table entry in the Hive metastore. But that's a manual thing and it can be pretty dicey. So once you call migrate, you really have to be confident that you're going to go forward with the Iceberg version and probably fix forward anything that isn't working. All right, and then the last one I'll talk about here that's related to staying inside the Hive metastore is add files. And this is useful in a lot of cases, like Cliff talked about some of them, where you have done a snapshot, but there's maybe new data in the table, and you want to add that new data to your Iceberg snapshot copy, or you want to try and keep them in sync over time, potentially. Add files can do that. So here you're just saying, what's the target table? Like what's my maybe Iceberg table? What's the source table of these files? And you can optionally provide a partition filter from the Hive table to, like, say, I want to add all the files from some partition in my Hive table to the Iceberg table. If you don't provide a partition filter, it will by default just try and add all the files. And if you run into any conflicts, like the file is already in the table, like let's say you did a snapshot command and you got a big chunk of the files, and then you ran an add files, but you didn't provide any partition filters, and you just try to re-add all the files into the snapshot. It's just going to fail the entire operation and say, I found duplicate files that you're trying to add to the table. So it will prevent you from adding dupes. By default, there's an option to override that. But you can use this to continually add files to your Iceberg copy of a table if you want to try and do some keep the tables in sync over time. One more thing on the add files, going back a slide, Cliff, is you actually can use add. Oh, sorry. I'm going to get on the next slide. I apologize. Yep, this is good. The other version of add files is not from a source table, but literally just from a path. So you can say, hey, I'm adding either Parquet or org files that are on some path. It will recursively go down that path and add any Parquet or org files it finds on that path to the table. So this is powerful, but dangerous. And so, definitely comes with a warning label. It is a way to you can create an Iceberg table. This Iceberg has to already exist, and you can add files from any random object store path into that table, provided the schemas match. But it doesn't do a lot of checking to make sure that you're not duplicating files, that the schemas match. It doesn't do the name mapping piece for you. So it can be used, but it's definitely sort of a power user mechanism. And you try to use snapshot and migrate as much as you can. All right. So all that talks about creating Iceberg tables still within the Hive metastore. But what if you want to actually have your Iceberg tables live in a different catalog? And because your plan is ultimately to retire, Hive metastore and get out of the Hive and Hadoop ecosystem, which there's a lot of reasons why that's a nice place to end up. In that case, what you need to do is, once you've created the Iceberg metadata, you want to register that table into another catalog. Let's say, Tabular REST catalog as an example. So there's a pretty simple procedure to do that. All you're going to do is, again, start this procedure with the catalog where you want to create the table, register the table into, provide a name for that table or a database name for that table, and then provide the full path to the metadata JSON file of the Iceberg table that you want to register. And every time you create Iceberg tables, you get a new version of this metadata JSON file. So just be aware that when you do this, you're registering a sort of a point in time of the table, and just pick the version that you want to do. And then you probably want to remove it from whatever catalog it was in. So if you'd created it in the Hive meta store, once you register it in another catalog like Tabular, you would want to remove that entry from the Hive meta store, being careful not to just call drop, because if you just call drop, depending on how you call drop, you might end up deleting the data files, and that's going to corrupt your Iceberg table, even the new catalog. So be aware that this is still reusing the same data files and same metadata. When you call this register table, it's not copying anything. It's just making an entry in the catalog. And so you don't want to go deleting any of the metadata or data files from that Iceberg table, because you will corrupt the table. All right. I think there was a bunch of Q&A. We covered a lot of stuff. So I'm going to go to the beginning. First question is related to, we did a Hive to Iceberg migration. We hit an issue due to HDFS erasure coding. I don't know about that particular issue. So I apologize, but I will talk to some of our experts internally, and we'll have to follow up offline on HDFS erasure coding. It is probably a good, again, thing to call out though is to think through as part of this migration, where do you want to end up? A lot of the value of moving to Iceberg is taking advantage of object storage and being more performant and getting out of the Hadoop ecosystem. Not that it can't work on Hadoop and HDFS, it can, but there's a lot of performance to be gained from getting out of Hive and Hadoop ecosystem. So as part of this migration, if you're on HDFS, I would strongly encourage you to consider, if you're going to go through this pain, also, do that move, make that move to an object store, whether that's a cloud object store or on-prem, like a MinIO. It might be a good opportunity to break ties with the Hadoop ecosystem. Second question, what are the best options to migrate Hive to Iceberg without touching the Hive table? We want Hive table to exist, create a new table in the existing data. So that's that snapshot command. I think we talked about that. When you use snapshot, now you have an Iceberg point in time copy of the Hive table, and they're independent. So you don't have to touch the Hive table at all. Not going to change anything there. And the challenge then is how do you switch over? If you want to switch over your users to the snapshot version of the table, to the Iceberg version of the table, how do you keep it in sync? I think you have to use things like add files. And this is something that the Tabular platform can help with. Like, we have some convenience mechanisms for snapshotting the Hive table, registering it in the Tabular catalog, keeping that Tabular Iceberg version of the table in sync with your Hive table, until you're able to then move all your readers and writers over, and then you can sort of decommission the Hive table. And that is sort of the zero downtime kind of migration that Cliff was mentioning. But there's definitely a lot more moving parts to consider, and something the Tabular platform can help with. Can we explain in more details on the limitations of using all Iceberg features in case of metadata migration only? Are there technical limitations? There are technical limitations. So I mentioned some of them, but I'll reiterate. One thing you often want to do with Iceberg tables is say compact Parquet files together. You cannot do that safely if you are sharing the data files between Hive and an Iceberg table. So until you decommission the Hive table and you just have an Iceberg table, you have to be very careful about rewriting any old files. You certainly can't use any of the more advanced Iceberg features like merge on read, where you have deletion vectors or anything like that. All of those will very much corrupt your existing Hive table, because Hive doesn't know how to deal with those files. As well as schema evolution, there are limitations there because of this field ID name mapping piece that I mentioned. And none of the hidden partitioning stuff is going to work. And all those are technical limitations. It's just the pieces aren't there until you're using native Iceberg APIs to write the Parquet files, you can't get access to any of those features. Next question is, can I have the migration happen in parallel and let the existing system still use the old implementation? I think we're talking about the snapshot world where you have, two tables running side by side. There's an example here. Stage new data, later be populated new table once migration is complete. Yeah, so this is what I was alluding to a bit, which is create a version of the Iceberg table using snapshot probably, where you've got the Iceberg metadata, it's in a new table, but you're sharing the existing underlying data files. Then as new data files are written to the Hive table, use something like the add files procedure to keep the Iceberg table in sync as you migrate all your readers and writers over to the Iceberg version of the table. And really there is actually move all your readers first, because your writers you have to continue to write to the Hive table until you have all your readers move over to the Iceberg version. And then once all your readers are moved over, you can then repoint your writes to the Iceberg table and decommission the Hive table. But there's a lot of moving parts there. This is, again, something the Tabular platform can definitely help with. What's the most common pattern across industry? Migrate entire data or just metadata? It's a good question. And I think Cliff answered this pretty well earlier in the talk, which is we see a mixture. It really depends. And the nice thing is you can make that decision on a table by table basis. And it really depends on, can you take downtime? What's the criticality of the table? Are there advantages in the Iceberg format you want to take advantage of? So all those considerations you have to go through a bit on a table by table basis. And we see mostly companies doing a mixture of both because there's just a lot of trade-offs to consider. Similarly, question here, pros and cons to using CTAS instead of migrate. I'd say CTAS is kind of the first choice option. It's the cleanest. You have a brand new table. You're going to rewrite all the data using native Iceberg APIs, and the Iceberg table you get on the other side can do all the things Iceberg tables can do. So that is usually my first option. The cons to it are that for large tables, it can be slow and expensive. So there's a cost impact for large tables. And we're talking like very large tables and things in orders of terabytes. Okay, fine. Petabytes is a different question. And then the other thing is you have to do kind of a cutover. Like if you do that CTAS, you have to then also coordinate moving your readers and writers over to the new version of the table. Otherwise, it's quickly going to get out of sync. And so it's a little bit more coordinated, but I do think I would say it's the first tool you should reach for if possible, because your end state is going to be so much cleaner. You can easily, do that into any catalog you want. You don't have to worry about doing register table or any of the other jazz. So if you can do a CTAS into the destination catalog and coordinate the cutover with your readers and writers, I would say that's the first choice. But there are trade-offs there. Andrew asks, is there a way to write metadata to another location, not the original tables ones, when running the migrate command? I don't believe that is true. You can set table properties as part of creating the table, but given the way the migrate procedure actually works under the covers, I'm not sure that would take effect right away. You would probably still end up with metadata on the original Hive path. You might end up with, and then future metadata might go into the table config path. It's a good scenario to test, Andrew. I'm not exactly sure what's happening there, but I wouldn't be surprised if that doesn't avoid having metadata land in the original table path. Do I need to use SparkCatalog only while migration from Hive? Probably. That's the SparkCatalog, and that whole SparkSessionCatalog bit is really only necessary when you are using the Hive metastore and you want to have both Hive and Iceberg tables that are in the same catalog namespace. Then you have to use a Spark catalog, because Hive the Hive Metastore, one of the downsides of the Hive Metastore is it doesn't understand multiple catalogs. Like you can't have Spark use multiple Hive Metastores. That's impossible, actually. It can only have one because all that configuration for the Hive Metastore is actually done in like your Hive site XML config for Spark. One of the advantages to moving to Iceberg and to newer catalogs is that you can have any number of Iceberg catalogs in the same exact Spark session. So it makes it very easy to join and share data across different parts of the organization, different environments. You can set up your staging environment to be read only for prod. So this makes it easier to do data testing and things like this. These are things that are impossible to do with the Hive Metastore. And one of the reasons I would say, moving on Hive Metastore is a good thing. So once you can get to, like Cliff mentioned, using three-part identifiers, including catalog as part of how you identify data sets, it really opens up a lot more flexibility in how your company can use your data lake. Next question from Hong is, so register tables when we have an Iceberg table and glue we want to the tabular. Yeah, that can definitely work. It's really, it's not limited to just glue to tabular. It's an open source procedure. So you have an Iceberg table in some catalog and you want to move it to a new catalog. You can have an Iceberg table in Snowflake and you want to move it to glue. That also works. So really, it's an easy way to move any table between catalogs. The key thing there is to make sure that when you're done with that, you sort of remove that entry from the previous catalog, because register table doesn't do that. And you don't want to get a situation where you have two catalogs that are both trying to write to the same table. That will likely end up in some corruption. Be careful there. Articles are examples of how to restore a Hive table from the backup. I don't know that exists, but it sounds like a great a great post that somebody should write up. So I'll pass that along to our DevRel team, and maybe they can take up the charge for writing up how to actually roll back from a migrate, because it is something that you will likely have to do at some point, and it's very non-trivial. So it'd be good to talk through all the gotchas there that we don't have time to cover today. All right, we're running up on time here, so I'll make sure if there's anything out there. Is the Hive Metastore still a bottleneck for queries after moving to Iceberg? No, that's actually one of the great reasons for moving to Iceberg. Even if you're still using the Hive Metastore to back your Iceberg metadata, all the metadata operations are moved to the file system in Iceberg. So the Hive Metastore no longer becomes a bottleneck. So that was one of the big design considerations. This was our problem at Netflix. The Hive Metastore was a huge bottleneck for us. It was a single point of failure. Iceberg was designed to solve that. So that goes away. Cliff is trying to answer some of these other ones offline. Streaming is super tricky. You probably will have to at least restart your streaming job to point into the new table at some point. So you'll have to coordinate, again, adding files that were written to the Hive table with, restarting your streaming job to start writing to the Iceberg table. It can be done. It's got to be coordinated. Add files, physically move files. So add files, no. Add files is still just going to create entries in the Iceberg metadata. It doesn't make copies of the files, so you'll still have the same exact original files on S3. It makes no copies. And in fact, the snapshot and migrate procedures use the add file procedure underneath the covers. It's just that it has less safeguards around it. You're not protected on schema, on duplications, on protecting yourself from accidentally deleting those files in the future. So just be a little more careful when you're using it. Can the loader also allow you to call the snapshot migrate add files measure to a function, or is the loader not using Spark? Peter, let's follow up offline since we're over time. And we're talking about Tabular's file loader.
Yes, he is. We've been answering questions on that offline.
Cool. Awesome. Yeah, we'll tackle that offline. It is using Spark under the cover. So most of the things are possible. And so this is where Tabular can help streamline your migration, where we can register the table in Tabular. We can watch the Hive path for new files and automatically add them to your Iceberg copy just again metadata add, not full copy. So you get this very efficient way to keep an Iceberg table in sync, and this allows you to do sort of no downtime migration of your readers and writers. Okay, we're right at time. I apologize that I talked a lot there, but hopefully that was an informative session. I don't know, Cliff or Rick, anything to take us out?
I just wanted to say thanks to everyone for attending, and we're happy to help. I would definitely recommend looking at your Iceberg questions. There's a wonderful Slack channel that you can find on the Apache Iceberg site to ask Iceberg questions. Or if you're looking for help with your Iceberg deployment, definitely reach out to us at Tabular. These are the kind of things we do all the time, and we're happy to be a part of your journey.
Yep, there's also a vendor Tabular channel in the open source Iceberg Slack. So if you want to get in touch directly with folks in Tabular, that's a great place to be able to connect with us.